All right, class, here we go. We are going to look at how to compute other values. Stop talking. To compute other values of trig functions. We must be mindful of their signs. They're S-I-G-N signs, not the S-I-N-E, okay? We're talking whether they're positive and or negative. Now, there is a helpful hint, and this is what drives me crazy. I've graded all of the first sheets of your worksheets that most of you turned in on Thursday. Now I'm grading the second side, and what I'm finding is that if you're making, you know what to do, but some of you are making careless mistakes with the signs, the S-I-G-N signs of the numbers. And guys, if you get the sign wrong, it's wrong, okay? Here's a helpful hint that I want you to go back and I want you to think about. When I draw the coordinate grid, and this is going to really hit us tomorrow, but you will see me, excuse me, write these letters. And you need to think in terms of first quadrant, second quadrant, third quadrant, fourth quadrant. ASTC, okay? And if you will look, this stands for, well, if you look in a textbook, any textbook, usually it will say all students take calculus. That is not a true statement. All students do not take calculus. But I do like this one. I like that one better. All-star trig class. Because y'all got it going on. Okay? Now, why am I telling you that little sentence? It's going to help you remember. If you go in the order of first quadrant, second quadrant, third quadrant, fourth quadrant, all-star trig class helps you to remember the signs of certain trig functions. Now, do certain letters up here remind you of anything we've been going over in the last week? What? Tangent, sine, cosine, right? All right, so, and you're exactly right. S stands for sine, and its inverse, which is what, folks? Somebody say it again. Cosecant, CSC. T, of course, stands for tangent. We must include its inverse, which is what? Cotangent. And then C, of course, stands for cosine. And its inverse, which is secant. Now, what's A stand for? All-star trig class. What's A stand for? No? That's a good guess. All. It stands for all. It stands for all what? All trig functions. And their inverses. All trig functions and their inverses. So, okay, what does that mean? All-star trig class. We know that S represents sine and its inverse. T represents tangent and its inverse. C represents cosine and its inverse. So what does all this mean? This helps you determine, and this is the most important part, folks. This graph, if you will, helps determine where the trig functions, let's put where the respective trig functions are positive. And folks, all this is just a helpful hint. That's all it is. It's just a helpful hint to tell you which trig functions are positive in which quadrant, okay? And I want you to think about this. Think about the signs. I wish I had a, maybe it'll do it. I don't know. Think about the signs of the ordered pairs in each respective quadrant. Folks, in the first, let's see, it won't let me do it. In the first quadrant, the ordered pairs are what? Positive, positive. And you will see me do this a lot. Positive, positive, positive. What do you think I do 3 of these for? Because this is cosine, sine, and tangent. Every trig function and their inverses are positive in the first quadrant. Everything's good in the first quadrant, isn't it? It's all positive. If we come over here to the second one, think about it. Don't even think about this S thing. Think about the ordered pair. The ordered pair in the second quadrant is going to be negative, positive, and then what does tangent have to be? Negative. Because there's only one positive value. And we get those from cosine, sine, and tangent. Only sine and its inverse are positive in the second quadrant. Think about the ordered pair over here in the third quadrant. It's negative, negative. Well, what's tangent have to be? Positive. Cosine, sine, tangent. Tangent and its inverse is positive in the third quadrant. And then down here in the fourth quadrant, cosine value is positive. Sine value is negative. What's tangent? It has to be negative. Cosine, sine, and tangent. You're going to see me write that tomorrow, every single problem we do. And the reason I do that, because y'all know how I am about careless mistakes. If it's an error with your sign, I want to gently elbow you right in the noggin. Gently. That's a lie. I want to like knock you out when you get a sign wrong. I'm like, no! Ugh! Because it's just, ugh, it gets on my last. I don't want you to make crazy mistakes like that, okay? So, helpful hint, all-star trig class. All this helps you determine is which function is positive or negative. Positive in which respective quadrant, okay? How are we going to use this? You're going to use this a different way, okay? You don't have to give me anything specific, but you are going to have some weird-looking examples, okay? The first one says, determine the sign of a trig function. What are we determining? The sign. We're determining whether it's positive or negative. That's all we're determining. I don't care about the real value. I just tell me positive or negative, okay? So for some of you, it's going to be very little work. I want you to tell me the sign of the cosine value of pi over 3. Think about it. Don't say anything out loud. Just think about it. Approach this problem. We all might approach this problem a different way. Of course, for me, what do you know I'm going to do? I'm going to draw a picture. That's the first way you can do this. And folks, for your notes, humor me and just write this down, okay? Because what if, at the end of this week, and I say, notebook quiz, and I ask you to show me the 2 ways to solve example 1 from February 11th, okay? But first way, I'm going to draw a picture. I know that pi over 3 is right here. I know that that ordered pair is 1/2 root 3 over 2, correct? I know that. I know that my cosine value is what? My cosine value is 1/2. The sine is what? 1/2 is what? Positive. Do you guys agree with that? Yeah? Now, is that going into a lot of detail? Yes, it is. That's a lot of details. That's a bunch of details. I don't even need that much information. Second way you can do this, some of you are literally going to think this in the air. You're going to think this in your head. But you're going to go, well, pi over 3 is here. That's all, so it's positive. That's all you're going to do. And you're not even going to write that down. You're going to think that. Okay? You can draw it. You can think it. As long as you get the right answer in the end, that's all I care about. Okay? But that's two different ways to approach this problem. Does that make sense? And what are we trying to prevent? What am I trying to prevent you from doing? Making careless mistakes. All-Star Trig class will help you all day long on this, okay? Not only for the straight-up sine, cosine, and tangent, but it will also help you when we're looking at their inverses. Let's look at another one. Same type problem. I want you just to determine the sine of these two values. The cosecant of 7 pi over 6 and the tangent. Let's go with that. Negative 2 pi over 3, please. Do that one on your own. Do both of those on your own. Tell me whether they are positive or negative. What did you guys do? Nate, what'd you do for this first one? You just did it in your head. 7 pi over 6. Let's think about it. All right, I'm going to put your thoughts on paper, okay? Did you go where? Third quadrant. You guys agree with that? Okay. Then what'd you think? All-Star Trig class. Oh, you're thinking the ordered pair. Negative, negative, which means tangent. Well, we don't really care about tangent, do we? Cosecant is the inverse of what, y'all? Cosine. So what is it? Well, if tangent's positive, cosecant has to be negative. That's right. Thank you. Still negative. Okay? I meant to do that. Totally meant to draw that face there. That's why I did it. Did you get negative? Cool. Yes, ma'am. Say that again. No, no, no. If it lands in the third quadrant, okay, according to All-Star Trig class, T represents tangent or cotangent, which means they are the only ones that are positive in that quadrant. Everything else has to be negative. Okay? Now, and here's the thing, folks. How many of y'all, do you remember doing those logic puzzles, those box puzzles that says, if John is married to Susie's mother's brother, and you check off a box, and Frank plays basketball on Thursday nights at the Y, and you have to check off another. Y'all remember those logic boxes? Yes, you do. I'm making them up, but I know you've done them before. You have to check off and eliminate things. This, to me, is like elimination. And I really have to think about this because I'm not real good at those logic puzzles. They are difficult for me. And that just is something that comes with practice. Do y'all know what I'm talking about? So, how many of you, yes, you understand, you know what I'm talking about, those logic puzzles. All right, where you X things out. And then, or I X them out to see what's left over to be my answer. Anyway, but this is what that reminds me of. It's like those logic puzzles on steroids. But, tangent. Now, how did you do this one? Morgan, you made eye contact. How did you do this one? Yep. All right, so did you think it or did you draw it? You draw it. Okay. Third quadrant, negative 2/3. Yep, I'll go with you there because you had to rotate down, right? So that's cosine, sine, tangent has to be. That's right. Tangent is positive. Right, all-star trig class. Tangent is positive, right? How many of you got positive? Okay, you were right. Positive for that tangent value. Does everybody understand how to figure this out? All-star trig class. Listen, please. It's so simple that you can kind of you can totally mess up on it. The thing you've got to remember is this all-star trig class means that these are the values that are what? Positive. They are the values that are positive. All-star trig class. And then just look. Look at your ordered pairs. Look at them. Negative, negative. You got to have one positive. Look over here. If I were to put this little review in your notes right now, everybody. I don't care if you think this is the dumbest thing. I don't care. Some of the things y'all say, like Ratchet, is dumb to me. So humor me, okay? First of all, we're going to write all-star trig class. We're going to write Q1, Q2, Q2, Q3, Q4. All right, now, signs. What are the signs in the first quadrant for everything? Plus, 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 right? Cosine, sine, tangent. You with me? Did we just write this above? We did. We're going to write it again. It's going to make us happy. S stands for what, y'all? Star, but it takes us to what? Sine and its inverse. So that means, but what's the ordered pair? Minus, plus. If I already have a plus, the other one has to be what? Negative. I can only have how many positives? The exception to the rule is the first quadrant. In Q2, 3, and 4, those quadrants, you can only have how many positives? 1. Very good. I saw it. 1. You can only have 1. Cosine, sine, tangent. Third quadrant. Negative, negative, what? Positive. Cosine, sine, and tangent. Please write that down. And then the fourth quadrant is positive, negative. Tangent has to be what? Negative. Because I can only have how many positives? 1. I can only have 1 positive. Meaning that trig function and its what? And its inverse. And its inverse. Except, what's the exception to the rule? The first quadrant. Quadrant is like, yay! It is beautiful. 65 degrees. Sunshine. Light breeze. Beautiful. Yeah. All right, here we go. Let's look at a different example. Worded a different way. Excuse me. I'm sorry I interrupt your conversations. That's so rude of me. It's example 3. 4, 3, and 4. Thank you. There we go. Here we go. If cosine of t is less than 0 and sine of t is greater than 0, in which quadrant does the terminal side of t fall? Look at, bless you, sneezy children, stop it. All right. What the world? This notation messes with me. I really have to think about it. It's that right there. Cosine of t is less than 0. What does that mean? Cosine is negative. If it's less than 0, that means cosine is negative. I don't know why that messes with my head, but it does. Sine t is greater than 0 means that sine has to be what? Sine is positive. Cosine's negative. Sine is positive. And folks, we're dealing with ordered pairs, aren't we? Cosine, positive. Which quadrant? Oh, yeah. That is right. That's all it's asking for. That's it. It didn't have the bar. Didn't actually have the bar on. Yeah, don't freak out. Hey, what? Facile or difficile? This is muy fácil. Here's another one. This is example 8. That's a lie. Just trying to see if you're paying attention. Most of you are. Some of you are not, ever. Not cool, Robert Frost. No, I'm just thinking in my head of you guys who continually talk in my class. To me, I know you don't think this is anything. It kind of borders on bless you. It borders on disrespect to me. And I know you don't mean to be disrespectful. Bless you. I can't. It grates on my nerves. And I'm just thinking in my head, not cool, man, not cool. And then the little dude, not cool, Robert Frost. I want one of those shirts so bad. Not cool, Robert Frost. Glass. All right. Hey, come up with this one. Do this one on your own. You already know? Just for me. Cosine's what? If it's greater than 0, it's positive. If sine is less than 0, it is negative. So I have an ordered pair that is plus minus, which is 4. Excellent. Atta girl. How many of you had Q4? Good. Questions at all? All right. So let's look at another one. Let me ask you something. In algebra, 2x plus 6 is called an expression, right? What would make that an equation? Add an equal anything, right? 2x plus 6 equals any number. That would be, or any variable. That would be an equation. Here's what you're going to do. Find the sign of the expression if the terminal point determined by t is in the given quadrant. Here's your expression. Sine times cosine squared over cosecant times tangent times secant. And it's in quadrant 2. Look at that. Find the sign of the expression, meaning not an equation, if the terminal point determined by t is in the given quadrant. So your expression is sine times cosine squared over cosecant times tangent times secant. That expression is in quadrant 2. Now let's think about this. I know, what the crap, okay? But you're right, I've got to go and figure out what the sign is for each respective function. but specific to where? Quadrant 2. Is all-star trig class going to be helpful to us? Yes, absolutely. All right, so quadrant 2. Here it is. Quadrant 2 is negative, positive, what? Negative, meaning cosine, sine, and tangent. Do you guys agree with that? All right, so now let's think. We're specific to quadrant 2. What is the sign, S-I-G-N, of sine, S-I-N-E, in quadrant 2? Positive. What is the value of cosine in the second quadrant? Negative. And notice that it's squared. Cosecant in quadrant 2 is what? How do I do that? It's all based on all-star trig class, based on the second quadrant, because that's what we're given, right? I know in quadrant 2 that my ordered pair is negative positive, correct? I also know from all-star trig class the only two that are going to be positive will be sine and its inverse, okay? All I'm looking at are the signs, the SIGN signs of these functions, okay? So if you look at sine, sine is positive. Stop talking.
I know that. I was asked about
Well, cosecant is the inverse of what? Sine. So what is it? No, it's the inverse of sine, so it's positive. So what is the sine of tangent in the quadrant, in the second quadrant, Tiffany? Thank you, Tiffany. Throw in your voice because you're a ventriloquist. Negative. No. Cosecant is the inverse of sine. Sine is positive, and its inverse is positive in the second quadrant. No, they are the same. The function and its inverse are positive in each respective quadrant. So sine and its inverse are positive in the second quadrant. Okay? So what about secant? Secant is the inverse of what? Cosine. If cosine is negative in the second quadrant, then secant is also negative. Holy moly. All right, here we go. Because they just kind of pair up together. It just is. No, no, no. The inverse is the reciprocal. Remember? It doesn't change the sign. Because if I tell you that the sign of a number is 3/4, you would tell me that the cosecant of that number is its reciprocal, 4/3. So you can think opposite, but it's not the opposite as far as signs go, okay? Now, what's a negative times a negative? Positive. So I'm going to do a little work here. What's a positive times a positive? Positive. What is a positive times a negative? A negative. What's a negative times a negative? Positive, right? What's a positive divided by a positive? Holy moly. All of that? Now, I'm going to just tell you, I made this problem up, and I made it way more difficult than what you're going to see in the book. The book problems are easy. So easy. Very, very simple. But all we're doing is figuring out the sign of that expression if it were to fall in the second quadrant. Okay? Now, we done. Here's what you're going to do for me. I've got to go get cards, like card stock for you guys, because we're getting ready to start making our special trigonometrical cheat sheet thingy. No, not Valentine's. No. Although we could do that because there are curves that are in the shape of hearts. I'm just saying. Let's, I tell you what, We're not. We're not. Smash them? Heck no. I don't make my family Valentines. Heck no. Why am I going to buy money on a piece of paper? Waste of money. Yeah. Take a planner. Waste of money. Waste of money. Here we go. 36. I just want you to look at this. I just want you to look at it and think about it. Okay? Because tomorrow I got to make copies of the unit circle. What 36 is, folks, it's a unit circle that is in terms of real number. If you look at it, it's got little tick marks all the way around the unit circle, okay? And what it means, if you count them off all the way around, like right here will be 3. And if you keep going all the way around and looking and counting all those little tick marks, when you get about right here, it says 6. Where do you think they're getting those numbers from? From the value of pi, 3.14, 6.28. That's what it's coming from, okay? Now, I know my picture is not accurate. I just want you to think about it because we're going to do those tomorrow, but I wanted to wait. I wasn't going to start it and then I just can't do that. It's very simple. It really is. But I want you to look at and think about number 36. Some of you will attempt that problem, and that's cool. That's fine. I will tell you this. I think the problem says cosine of 0.8. Well, if I'm looking at it, folks, what I want to do is I want to count to 8 tick marks. 1, 2, 3, 4, 5, 6, 7. And this is a horrible drawing. But let's say that this was, let's say that was 1. Then I know that this is 0.8. And then you're going to drop the altitude. And you're going to have to think in terms of sine, cosine. Some old horse called a horse taking oats away. You may have to use the Pythagorean theorem to find the third side of that triangle. I just want you to think about it, look at it. Okay? You do not have to do number 36, but you can look back in your book and see if there's an example to get you prepared for tomorrow. 43 through 50, straight up what we did in class today. You should be finished with this before you leave.